Good afternoon and welcome to Homework Help with Miss Ivory. Today we're going to go over homework number 16, which is pages 389, numbers 30 through 38, and page 401, numbers 27 through 30. I'm going to start with example number 31, which is x squared plus 5x minus 14 equal to 0. They're asking us to solve the equation. Before we solve the equation, the first thing we want to do is make sure that one side of the equation is equal to 0. As we can already see in this example, the right side is in fact equal to 0. So the easiest way to solve the quadratic from here is to factor the trinomial we have. Being that we have a trinomial, the first thing we want to do is check to see if it's a PST, a perfect square trinomial. We can determine whether a trinomial is a perfect square trinomial by looking at the A and C of the equation. In this case, our A is x squared and our C is 14. We can get a perfect square from x squared, the A, but we can't get a perfect square from C. So our answer to our question is that it is not a perfect square trinomial. Being that it isn't a perfect square trinomial, my next method I'll use to factor is the AC method. In order to use this method, I'm going to create an x, and I'm going to multiply A and C, and put that in the top here. Our A value is 1, and our C value is negative 14. So when I multiply 1 and negative 14, I'm left with negative 14. At the bottom of our x, we're going to put our B value. In this case, it's positive 5. Now that we've written our A and C and B values, we want to find two numbers that both multiply to negative 14 and add to positive 5. I'll find these two numbers by writing out the factors of 14. So we know that 1 and 14 is a factor. We know that 2 and 7 is a factor. I'm going to test 2 and 7 because I feel like we may get lucky. 7 and 2. Now we know that 7 times 2 is 14, but in this case we're looking for negative 14. So we know that one of our numbers, 7 or 2, are going to be negative. Now when we look at 5, we know that when we add them together, it has to be a positive 5. Being that it has to be a positive 5, I already know that my 2 is going to become negative because our larger number, 7, has to be positive in order for our B value to add to a positive number. Now that I've used the AC method, I'm going to create two binomials using the two numbers I found to satisfy my AC and B values. So now I have x plus 7, and then I have the second binomial of x minus 2, all equal to 0. Now, being that we're solving this equation, we're going to set each factor equal to 0. So my first one, I'm going to have x plus 7. Let me move the parentheses, sorry. X plus 7 equal to 0. I'm going to use additive inverse property, and I'm going to be left with x is equal to negative 7. Now we're going to do the same thing for our second binomial. We're going to have x minus 2 equal to 0, and using the additive inverse property, we are going to add 2, and we are left with x is equal to positive 2. Now that we have the values that will satisfy this equation to equal to 0, we must check our work. I'm going to start with negative 7. So I'm going to plug in negative 7 into each x value into our quadratic equation. So I'm going to put parentheses negative 7 squared plus 5 parentheses negative 7 minus 14 is equal to 0. After plugging in each value, you'll get negative 7 squared is positive 49. Positive 5 times negative 7 gives you negative 35. And minus 14 is equal to 0. From here, we're going to keep evaluating. We know that 49 minus 35 is 14. And then we just bring the next 14 down. And 14 minus 14 is in fact 0. So that proves our equation right. For our second check, being that we have two solutions, we're going to do the same thing. We're going to plug in 2 for our x values now. Here, we have 2 squared, which is 4, plus 5 times 2, which is 10, minus 14, equal to 0. 4 plus 10 is 14, minus 14 equals 0, and again, our work checks out. It's important that you check your work each and every time that you find your solutions for x. Okay, so now I'm going to review example number 28. This is actually an example that you have to do for homework, so pay extra attention. For number 28, they're asking us to solve the equation again, just like in example 31 I did with you. The equation given is 4x squared equal to 49. Now, as I said in our other example, we always have to make sure that our quadratic equation is equal to 0. With this given quadratic, we can see that one side isn't equal to 0. So in order to make it equal to 0, we will use our additive inverse property. Let me change the color of my writing. And we're going to bring it to both sides. When we do it to one side, we do it to the other. So now we have 4x squared minus 49 is equal to 0. Looking at this quadratic equation, I noticed two things about it. Instead of it being a trinomial, we now have a binomial. And in our binomial, the operation is subtraction. This rings a bell to me. It tells me that I need to look to see if this is a dots example. Dot stands for difference of the squares. So in order to determine if it's a dots example, I'm going to look at each term and determine if I can get a perfect square from each one. Looking at 4x squared, I know that I can get the square root of that. And 49, I know that I can get a square root of that. So now let's get to it. The square root of 4x squared, well, the square root of 4 is going to be 2. And in order to find the square root of an exponent, we always have to divide the power by 2. So when we divide x squared by 2, we are going to be left with 1. So now we have 2x. For our next term, we have 49. We know that the square root of 49 is 7. So that's how we set it up. Now you may be wondering why I didn't put an operation in between each binomial. And that's because when we deal with dots, we know that our factored binomials are going to have both subtraction and addition in each. Well, each binomial is going to have subtraction and the other is going to have addition. So I'm just going to plug that in here. Addition and subtraction. So our factors for 4x squared minus 49 will leave us with 2x plus 7 and 2x minus 7. Now let's not forget, the original equation is to set it equal to 0. So we still have a lot of solving to do. I'm going to break down each binomial one at a time. I'm going to start with the first one, 2x plus 7. So here I have 2x plus 7 equal to 0. Here we're solving for x, so the key is to get x by itself. In order to get x by itself, I have to remove everything to the other side of the equation. I'm going to start with 7. So I'm going to use my additive inverse and get rid of 7 by subtracting it. So now I'm left with 2x equal to negative 7. I'm still trying to get x by itself. So now the only thing I'm left to do is divide by 2. And here I have x is equal to -7 over 2. For the next binomial, we're going to do the same thing. We have 2x minus 7 equal to 0. We're going to do the same thing. We're going to use additive inverse to get x by itself. We're going to start with 7. So now I have 2x is equal to 7. And again, to get x by itself, we're going to divide by 2 on each side. So now we have x is equal to positive 7 over 2 and negative 7 over 2. And of course, you must check your work, but being that I already checked my work in the other example, you guys don't need me to model that for you again. Okay, enjoy doing the rest of your homework. I hope this helped. Signing out.